What is on the screen now? Are you guys seeing the screen now?
Yes, we're seeing it now.
All right, then good. Okay, so I'm going to begin. So this is question 1. All right, it reads, an experiment was carried out to determine the energy change for the reaction of magnesium metal and hydrochloric acid. The procedure is given below. This is the procedure. 100 dm cube of 0.5 moles dm cube hydrochloric acid was measured out and placed in a colorimeter. Sandpaper was used to clean a strip of magnesium metal until it's shiny, and 0.48 grams was weighed using a balance. All right, I'm going to circle the key things as we go along. So the 0.8 grams that they use, that they weighed out. Step 3, the temperature of the hydrochloric acid in the colorimeter was measured every minute for 5 minutes until a constant temperature was obtained. And step 4, the magnesium strip was then added to the colorimeter with hydrochloric acid while stirring gently with the thermometer. You guys know you should have stirred the thermometer, but it's there. The thermometer was recorded every 15 seconds for 2 minutes. And then the last step, use the first 5 temperature readings taken during the experiment. All right, this goes up. So we are going to just read off the temperature readings from the thermometer and use that to fill out the table below. Okay, let me start then. For is 5 this one is reading 30 degrees. Yes. Right. Okay, so anyone wants to give me the second temperature reading?
Was that 39.5 degrees Celsius?
Yeah, exactly. It's 39.5. The third one,
43.
yes, correct. The fourth,
44.5.
okay. And the last one is
46.
46, correct. All right. So we're just gonna put these into the table. What's that? You were speaking to me? All right, so this temperature reading from the table, we can see that the highest value we're seeing is 46, and this 46 is the highest temperature that was reached during the experiment, and so that value is important because it shows where the reaction ends, right? So you're gonna plot a graph with this information. You guys are familiar with plotting graphs, right? I assume you guys. So I'm not going to plot the graph right now, but I'll just work around the other questions regarding the graph because you don't need the graph to answer. You can do it another way. But as long as you're familiar with plotting graphs, then that's the temperature change, delta T for the reaction. So when you draw your base curve on the graph, imagine it to go up and peak at the 6 degrees Celsius. So it's peak up here. Let me attempt to draw an example of the curve that we'll be getting. It will up. And it will peak somewhere over here with 46. It will be the highest temperature reading from the graph, and the lowest temperature reading will be 25 degrees Celsius. And where I get that value from is on the you can see at 0, really 25 degrees Celsius. So the change for the reaction would be the 46 rather, which is the highest temperature reading, minus the lowest temperature reading, 25, and that should give us 21 degrees Celsius. Everybody getting that? You guys following?
I see the sense of joining this one.
What's that? I didn't hear you. Sorry. Did everyone understand this so far? Or should I go over anything?
No.
All right then. Okay, so it says to state one difference between exothermic and endothermic reactions. Anyone knows the difference? Okay, so in endothermic reactions, those are the type of reactions that require heat. So heat is being used up in the process, whereas in exothermic reactions, heat is given off when they react. So from that explanation, could anyone give me a difference between them?
I could try during endothermic reactions, the environment which the reaction is taking place would get warmer. No, would get cooler, while doing exothermic reactions, the surroundings would get warmer.
Okay, that is a fair attempt. So we wouldn't say the environment because
Miss, could I attempt? With endo and exothermic reactions?
All right, so I'm going to write it out. In endothermic reaction, heat is absorbed, and this will mean that heat change. Okay, so just a simple explanation like what I have on the screen would give you the 2 marks for this question. So saying that endothermic reaction, yes.
I'm not seeing anything, just the blank screen.
Anyone else having that issue?
Business.
You're not seeing? Hmm. Okay, seeing it now?
Yes, I'm seeing it now. Thanks.
All right, good. All right. So in endothermic reaction, heat is being absorbed into the reaction, and in exothermic reaction, heat is being given off. And this example right now is an exothermic reaction. You did a lab, right, where you react magnesium with hydrochloric acid for your SBA. Did you get anything like that to do? No. All right then. All right. So what I was saying is that by observing the experiment of reacting magnesium with hydrochloric acid, you will see that effervescence is being given off when you react the magnesium. Upon direct contact of the magnesium with the acid, you'll see tiny bubbles. These bubbles would be hydrogen gas, and you could feel that the beaker itself feel warm. So these indicate that it's an exothermic reaction. Therefore, you could put that this reaction is an exothermic reaction. All right, so for B, section B, write a balanced chemical equation including state symbols for the reaction between magnesium metal and hydrochloric acid. All right, so for this reaction, let's just start by writing down what we are reacting. We are reacting magnesium And remember to put the state symbol. So magnesium is a solid with hydrochloric acid. And hydrochloric acid is dissolved in solution, so it's aqueous. And this will yield magnesium chloride and hydrogen gas. And gas is a okay. Writing the equation this by itself will give you 2 out of the 3 marks. So you will need to balance it. Over here we have 2 hydrogen gas is dented by 2. So we'll need 2 moles of hydrochloric acid here. And since you have 2 moles of chloric acid, we need to have 2 chloride over on this as well to balance the equation. That would be the correct balance equation. All right, so
Excuse me,
the
miss.
number of moles of magnesium used in the reaction, yes.
Did you just
Yep.
put the 2 behind the magnesium chloride?
Yes, to indicate that there are 2 chloride ions present. Over this side, let me unbalance it so to explain it.
Yeah, yes, miss.
All right, you get it? So put it here because it's not 2 if it was 2 magnesium, we'd put it here instead of at the end there. But we have 2 chloride ions from this part, so we'll have to put it at the end. Understand? Let me know, you know.
Well, miss, was the 2 there before it was balanced?
No.
So I thought that
Why
you
we put the
couldn't.
2?
I thought that you couldn't change the number that was behind the element, miss.
Yes, you're not supposed to, but when we react, from what we know, right? When we react magnesium with hydrochloric acid, hydrogen gas is given off. Hydrogen gas is 2 hydrogen atoms combining to form hydrogen gas. So you don't have hydrogen gas just existing as H in the air anyway, right? So because of that, we will need to react 2 moles of hydrochloric acid instead of 1 mole of hydrochloric acid here. When
Yes,
we
miss, I
react the
understand
2
that part.
moles, what's that?
I understand that part. It's just the fact that you put it behind the number behind the element. That's the part that's confusing, miss.
Oh, that is where it goes, man. That's where it goes normally.
What?
Yeah. If it was a molecule where let me see. If it was, for instance, something like carbon dioxide, then you'll put the 2 in front because it is 2 carbon dioxide molecules that are being produced. But in this case, it's just 2 chlorine ions and not 2 moles of the entire magnesium chloride. Does that explain it better?
Yes, miss.
Yes, so if it's something that's a molecule, you'll put it as so there are 24. Yes, 24 grams of magnesium.
This is screen one.
It's got, oh, okay. All right. So 24, calculate the number of moles of magnesium using the reaction. All right, so 24 grams would equal to 1 mole. So we will cross multiply. Let's see. Okay, so go back up here to the top of the question where we have the 0.48 grams. So this number, the 0.48, is the amount, is like the mass of magnesium being used. So that will equal to the 24 down here. Down here. Okay, so 0.48 It's a very crooked line. Right here. Could anyone come here, the value of that? Work it out. 0.48 times 1 divided by 24.
0.02.
All right, thanks. To place at standard temperature and pressure. Now, hydrochloric acid was used initially.
Mrs. Screen stop
And
sharing.
we'll write about the equation. Yeah.
The screen down.
Oh, I'm having internet connectivity issues. That's why. All right, let me write about the equation now. All right, so from this equation, we can see that 1 mole of the magnesium produces 1 mole of the hydrogen gas. So therefore, at room temperature, 1 mole of the
Excuse me, miss.
magnesium would, yeah,
Where did that 0.48 come from, miss?
all right, so the 0.48 would be the mass of magnesium used. Let me go back up to the question. So I highlighted it here. So right here where they said the mass is weighed out. Yeah.
Okay, thanks.
All right. Everybody's seeing the screen now, right?
Yes, ma'am.
Yes, miss.
Okay, so, all right, good. Okay, so the 0.02 moles that we calculated here for the number of moles of magnesium used would give us would help us determine the volume of gas used. So let me just write out the formula for that. So 0.02 moles of Mg here we're just cross multiplying again. And could somebody tell me the value that they get for that? 0.02 times 22,400 divided by 1.
Miss 440.
Okay, 448 centimeter cube of hydrogen gas. Is everyone clear on that?
Miss, I can go through,
Yeah.
we can go over it, please.
All right, no problem. So what I would do is write about the equation here. And from the equation, I can see that 1 mole of magnesium, highlight it at all. 1 mole of the magnesium here would give us 1 mole of hydrogen gas. The 1 mole of magnesium is equivalent to this volume that they give us in the question here, 22,400 centimeter cube. So when we like cross multiply that with the moles, like we're using unitary method, for instance. So to get the 1 mole of, to get how much 1 mole would give us, we would multiply it by the volume, the number that we calculated up here, 0.02 moles, times this volume down here, which is like the unit molar volume, and the amount that that gives us would tell us the amount of gas present, like the volume of the gas present. If anything, you could just look it over. They have like the formulas for this explained out properly in them. All right, then. All right, to the next question. Calculate the energy change for the reaction between magnesium and hydrochloric acid. All right, so for energy change, the equation that we will use for that is, well, they give M times C times delta T. The delta T is a change in the temperature, and they let us calculate that before. So let me go back up to see what we got for that. Yes, so that we calculated that to be 21 degrees Celsius for the change in temperature. So keeping that in mind, I'm just start it out here. So that's the change in temperature volume. The mass would be from the question. I think they give us 100 centimeter cubes of hydrochloric acid to use. Yes, so here it is, 100 centimeter cubes of hydrochloric acid was used. So that's where we get mass from. The heat capacity that's given right here in the question. So multiplying that, could somebody tell me what they get? Like all they're doing for this question is just multiplying using the formula that they gave.
Miss 8,820.
Okay, so 8,000.
Miss, would it be negative like how it's an exothermic reaction?
Yes, I'm glad you noticed that. So the energy change would be a negative value. And you know, we can write it as kilojoules, which would be 0.82 kilojoules. And that would give us the 3 marks right there for that question. All right. Determine the energy change per
Okay,
mole.
scroll it back a little bit, please. Wait,
Everything now?
miss, you know, some sort of division of one, to transfer it into, to convert it into kilojoules, miss.
Yes, but they didn't ask us to give us in kilojoules, so either is fine. So whether you write it in joules or kilojoules, then that's fine. To convert to kilojoules, you know, you just divide by 1,000. And then it will be 8.82 kilojoules. All right. Is everything
Yes,
okay
miss.
now? Okay.
Yes, miss.
Right. So determine the energy change per mole of magnesium. So this energy change that we calculated was for the entire reaction, right? But we want to figure it out for just the mole of magnesium that is given. And to do this, we use the number of moles of magnesium in the solution that we calculated, and we had determined that to be 0.02 moles. So let me start by writing that. 0.02. And this would give us the energy change that we calculated above. Negative 100.
Miss,
Yes.
we never got any of that on the screen is black.
Oh. All right, just let me know when the screen logs off because I can't tell, but I'm having internet connectivity issues, so it will just jump off times.
Okay, Miss, you can do
I mean,
that, please.
it's off. Well, all right. Let's explain it, you know. So, right, so the 0 point, so it says to determine the energy change per mole of magnesium. So per 1 mole of magnesium, we want to determine how much like energy change take place. So we know from what we calculated above that, let me go back up. All right, so calculate the number of moles of magnesium used in the reaction. So this question here tells us that there is 0.02 moles in the entire reaction that is taking place right now. So we know for sure that 0.02 moles is in the reaction. That 0.02 moles gives us an energy change that we calculated here to be negative 8,820. So to determine the energy change per mole, which is per 1 mole, we would just divide the negative 8,820 here by the 0.02 mole that we know for sure in the reaction, and that would give us what 1 mole of magnesium would give us an energy change. So let's divide. Is that clear?
Yes, miss.
All right, and when you divide that, could somebody tell me what they get?
441,000.
All right, for
Miss, what do you like? What will I do first? Eh?
What's that?
Class. Nobody would know he had different lines.
141.
Mm-hmm. Yes.
Mixture gone again.
All right. Let me share the screen again. Okay, so steels are alloys widely used in industry in place of metal iron. Let's define the term alloy. Does anyone know what's an alloy?
Yes, miss.
It's the
A mixture of metal and non-metal.
Of metal and non-metal. You have part of it. Try again. That's the last part. Need fixing up.
It's a mixture of two metals, miss.
Yes, exactly.
Wait,
So,
miss, actually, but
Mhm.
I have heard that in a class, the mixture of a metal and non-metal. I've heard that before, actually.
Really? All right. So,
Yeah.
well, you know, metals like mercury can be non-metals at room temperature. So probably that's what they mean, but it is two metals. So it have to be metal properties because for alloys are basically the mixtures of metals to give us better properties of the metal that wouldn't exist naturally by itself. All right, so example, brass and steel. Anyone knows the type of steel? This is kind of like general knowledge. I'm not sure if they went over this.
Miss stainless.
Yes, that's one.
And mild steel. Mild.
Mild steel. Okay, stainless steel. Okay, any more? No, I said two, but you know, you could always have more in mind. All right, so I know of carbon steel as well.
Reinforced steel, miss.
What's that one?
Wait, reinforced steel. I think it is carbon steel because that them use to reinforce it.
Okay, all right then. So stainless steel, mild steel, and carbon steel. So two advanced properties of steel. So everyone is familiar with stainless steel. So just think about that and like, what are some properties that stainless steel gives us? in everyday
Is
use.
it doesn't rust?
Exactly. So it prevents corrosion. You probably don't think of this one, but with the carbon, I know that it is stronger than the regular steel. Carbon forms very strong bonds, like in diamond and sand. Carbon steels. It doesn't break that easily. All right. Just for general knowledge, let me give an example of the stainless steel, not example rather, but the stainless steel is a mixture of, that's right, what they are a mixture of. It's a mixture of iron and chromium. Example on mild steel. What is the mixture of air steel? It's a mixture of carbon as well. So it's a mixture of carbon and steel. So mild steel and carbon, same thing. Right. Section B. Many metal nitrates undergo thermal decomposition. The relative ease of decompositions and the product form can help determine their place in the reactivity series. Table 2 below shows the products formed from the heating of the nitrates of 5 different metals, V, W, X, Y, and Z, respectively. All right, using the information from table 2, state which metal would be more reactive and which metal would be less reactive. All right, anyone wants to give this a try? You guys still hearing me?
Yes, Miss. The more reactive metals would be W and Z, and the less reactive metals would be Y, X, and V.
All right, yeah, that sounds correct because from the table you can see W and Z give metal nitrate and oxygen, whereas Y, X, and V, Y, Z, no, V, X, and Y have metal oxide, nitrogen dioxide, and oxygen. So more product is being formed, so that would indicate that they are less reactive. So write that in.
I'll give them.
Right? If one of the more reactive metal was identified as sodium, write a balanced chemical equation for the decomposition of sodium nitrate. It's just sodium and nitrate together. And it's a solid at room temperature, so you put in the state symbol. When things are undergo decomposition, it gives off oxygen gas. We'll just write the formula for it to show that. Is everyone getting that? You guys following, right?
Yes, miss.
All right then. Okay. Further tests were carried out with metals V, X, and Y. Each metal was oxidized of the other metals in displacement reactions. V did not react with any of the metal oxides. X react with the metal oxides of V and metal Y, successfully displacing the metal. So you see that it's displacing both of them like readily. That would indicate that it's very strong. Y react with the oxides of metal V, successfully displacing the metal. So Y would be relatively strong. So using this information, reactivity of the metals V, X, and Y from the most reactive to the least reactive. Right, so from the most reactive, we will see that it is X right here that is displacing both V and Y. And we use the sign greater than. Y would come second because it is displacing metal V. And then last we'll have like V. So just that and you get 2 marks right there. Right, section C now. Tests were carried out on solution A to determine the cations present. The observations are present in table 3. Complete the table by inserting the inferences based All right. So when you see green precipitate being formed, this indicates that it is iron, ions being present, and the type of ion would be Fe2 plus. I think there's a table in the book that like explain all of the possible inferences that you can look through and familiarize yourself with this somewhere so you can just remember them. And when it stands, it turns to iron Fe3 plus. All right, colorless gas. All right, a few drops of dilute sodium hydroxide were added to a small portion of solution A in test tube. The test tube was gently heated. All right, upon gently heating it, colorless gas evolved with a pungent odor. Gas turned damp red litmus paper blue. Colorless solution formed. All right, so pungent odor would indicate ammonium rather. No, it's ammonia. And that is NH3 plus. And colorless solution formed. Is ammonium ions being formed. So NH4. For this section of the paper, you just have to go over the list of possible inferences and observation from the table in the chemistry book and just try to memorize them at this point. It's just remembering and writing them back, essentially. All right, so on to question 3. Figure 3 shows compound A and compound B, which are from different homologous series. Say the homologous series to which compound A belongs. All right, anyone wants to give this a try?
It's carboxylic acid. Carboxylic acid.
All right, so the functional group would be the carboxylic acid right here, and I have it circled, so I don't have to fill in that part. Going to naming the compound now. I'm not sure if you heard me when I was trying to explain this part, but essentially what I was saying is when we're naming compounds, we look for the root, which is the longest chain of carbon atoms joined together in a non-broken format, and that would be here, the 4 carbons being joined here. It doesn't have any double bond in between them, so that indicates it is an alkene, so you know butane. But because we have the carboxylic acid group on the end, and carboxyl groups have a higher priority than the alkane, how would we name this property? Anyone wants to give it a try?
It's alkenes.
Alkene? No, it wouldn't be an alkene, because the carbon, for it to be an alkene, it would have to look like this one, where we have a double bond in between 2 carbons in the longest chain. Here, we don't see any double bond in between. We have a double bond between an oxygen, a carbon, which is attached to an oxygen and a hydrogen, carboxylic acid group. So we will give the carboxylic acid group priority. So know that carboxylic acid or anoic acid should be in the name.
But botanic acid.
All right, so just bear with me. The internet is giving me a hard time. Where was I? The name of compound B. No, the name of compound A. And I was saying that the name would be butanic acid. All right, so the question after that states whether compound A will undergo a condensation reaction or addition polymerization reaction with alcohol. Compound A is a carboxylic acid. When we combine carboxylic acid with alcohol, that is esterification.
Is it as a double bond?
All right, just checking if you guys are hearing now.
Yes, miss.
Okay, so I'm just gonna, because of the internet issues that I'm having right now, I'm just gonna go up until section B and then pause it there for today. All right, so state whether compound A will undergo a condensation reaction or an addition polymerization reaction with alcohol. Compound A is a carboxylic acid, as we said, and carboxylic acid upon reacting with alcohol is esterification. And that process is a condensation reaction. So that would be the answer here. Condensation reaction. B now. State the homologous series to which compound B belongs. And this is compound B. And we can all tell that this is an alkene because it has a double bond and there is no other group on functional group on it. So an alkene. Functional group of compound B, C double bond C. Write the name of compound B. So anyone wants to name this compound?
Miss B with one in.
Yes, that's correct.
Wait.
Just respond on that. If you don't write the one, it will not be correct. So if you just write
What if I just Go away. I was like, anyway. Sorry to interrupt. Continue, please. Hello, Miss.
Yeah. Yes. You have a question?
No, Miss, I couldn't hear anything just now. I was checking it. That's around
Yeah,
by my end.
no, I had disconnected. As I said, the internet is really bad. I don't know why, but it's not working right now. And it normally works, you know. It's just the devil, I guess. All right. So here it asks to define the term structural isomers. So anyone wants to give me that definition?
I did. No, never mind.
No.
They have the same molecular formula, but different arrangement of atoms.
Yes, that's correct. So it has same molecular formula, but different arrangement of atoms. All right, so that's adequate. And the name for this, just naming it right now. It is is it pentene or pentane? Does it have any double bond?
It's pentane.
All right. It's a pentane because there are no double bonds present. Okay. Draw the fully displayed structure of two structural isomers of compound C. So I'm just going to go right ahead and draw them. This later. So that's structure. Another one would be structural isomers are just change the position of how you bond carbons, but just make sure you don't add anything extra. Don't add any. So using the same number of carbon and hydrogen that they gave you, just try and draw different ways to position them, and then you can just get the concept. Just use the amount of carbons and same amount of hydrogen that they gave in the original question. Draw them back. Anyway, it doesn't like replicate one that you have before, and you will get an isomer. All right, so that is 2 examples of the isomers. So the name of isomer 1. Anyone want to attempt to name it? What's the longest chain of carbon that we're having?
Ethyl.
Ethyl.
Butane.
Butane, miss. Butane. No, butane, sorry.
Butane, yes, that is correct. All right, so this butane, and then we have these are methyl groups, and there are 2 of them. So try and name it for you now. Yep, that is correct. 2-methyl butane, 2. All right, so that's the compound 1. Compound isomer 2. We have the longest chain is pentane.
Is it 2? Wait, hold on.
It's 2,2-dimethyl-propane.
Yes,
Yeah.
that's correct. 2,2. And we use comma to separate the 2 numbers. And when you're in between words, we use dash, and between difference, if you get a different type of question, remember that when naming the groups, so for instance, you have an ethyl group instead of a methyl group branching, you would put the ethyl group first because they use alphabetical order when naming them. All right, so we reach to section B. I was hoping to pause here, but the internet hasn't disconnected me yet, so let me try and attempt this part now. All right, so figure 5 shows a line diagram representing the electrolytic cell using the electrolysis of aqueous copper 2 sulfate solution using copper electrodes. State whether the electrodes are active or inert. Give a reason for your answer. Active is taking part in the reaction, whereas inert means it's just. Why would you say it's inert?
Because they're both. Because none of them have show decomposition, miss.
Okay. I would actually say it's active enough. Anyone has a different answer?
No, miss, it is active.
It's active. Yes, that's what I'm thinking as well. And that is because they like take place in the reaction, because it is copper 2 sulfate. I'm just working what I am familiar with in the lab. This is why it's important to like pay attention in the labs. Yeah.
Oh, copper. Oh, I never said that part there.
Exactly. Okay, now when you use copper 2 sulfate, you will have the copper being deposited on the copper, and it will look like gets bigger as the reaction proceeds. So it is actually taking place in the reaction and therefore will be active.
Miss.
Yes.
Doesn't the copper from one of the electrodes go into solution as well? And then gets deposited onto the other electrode.
Yeah, basically. Wait, let me see. Using copper electrodes. Yes, they're using copper electrodes in copper 2 sulfate solution.
Miss, I can't hear you.
Yes? Yeah, I got disconnected just now. All right. Describe what occurs at the cathode and the anode in an electrolytic cell. All right, so the cathode, this is where, so cathode is positive, and this is what accept the positive cations, and anode is negative, so it accept the negative anions. So to write that out, so remember, just use that, like cathode go with cations and anode go with anions. All right. This is random, but one way to learn to remember which one is the positive and which one is the negative is when we're spelling out the word cation, we will have the T, so we'll write, try and draw it. And then we'll just use like a plus sign as the T, and then the rest of the word cation. And once you remember that the plus sign is in cation, so it is I am thinking to just end here for today, given that the internet is really not allowing me to continuously, like as I would finish the paper, and I would send it to Mr. Phillips so that you guys can get the completed paper with all the answers to look at, and I'll try to write a little explanation besides them, and would possibly try and hold another session for the multiple choice aspect of the paper and go through as many multiple choice paper as best as possible. Are you guys okay with that?
Sounds like a plan. Yes, yes.
All right then. So all the best on paper 2. I'll try and get you guys this paper between this evening and tomorrow. And then we'll just come in touch for paper 1.
Yes, yes.
All right then. All the best, guys.
Same to you, Miss Goodbye.
Okay, bye.